Today's class will be focused on the Python function. So we will be learning about the Python function basics, and then we will review a list of commonly used Python building function, and then I will introduce the user-defined function concept. So how you can define your own concept in terms of function and then use them. Before, let us try to understand what does the concept of function mean. A function, by definition, is a name block of code that is defined once, okay, and can be called many times to perform a specific task or operation. So as you can see in this illustration, you have two functions, function 1, which is defined here, and function 2. So since in function 1, we need to implement the functionality, which is defined in function 2. Instead of duplicating the code, we just have to call the function 2, which implement a specific operation in the function 1. So this is the approach of defining the function in Python. So what is the basic idea behind the concept of function? Is to put some commonly or repetitive done tasks together and make a function. So instead of writing the same code again and again, so we can just define that code in a named block, which is called a function. And then whenever we need to perform that operation, we can just call the function and reuse the code which has been implemented in the function. The basic idea behind the function is to put together commonly used or commonly performed tasks which are repeatedly used. So you can make them in a block, call a function, and then you can just call or use the code wherever you need it. So this is the most optimal way to implement a complex or big size program. The following are the characteristics of a function in Python. A function basically is defined with a unique name. So like any other object we have seen so far, so they have an ID which identifies each object we define in our domain to be unique. The second characteristic of a function is that a function can run only when it is called or invoked using its name. So to call a function, we use the name of the function to run the function, so the function can give back the result or the functionality we are expecting the function to perform for us. Third, you can pass data to a function while calling the function, which are known as parameters or arguments. So they can be sent to the function when we call the function, and then a function can also return a result or data to the environment that is called the function to use that output coming from the function. These are the 4 main characteristics of a typical function in Python. So what are the benefits of using function? So function basically increase the code readability. So it's help us to organize the codes in logic chunk, okay, that can be reused again and again. So they help us to increase the code reusability. That means you define a logic once, and then you can still use it without writing again the code several times. It's also make it easy for the maintenance of the code. So you can test the codes or the part of the code separately and debug when you have issues within a simplest way. Last but not the least, it's also improve the optimization of the code. So it can help us to optimize our code instead of duplicating the same code again and again, which can be messy and can lead to many issues in terms of duplication of variables or objects. So in Python, as a programming language, functions are reusable block of codes that perform specific tasks as they've been defined. So as I mentioned earlier, they help us to organize the codes, avoid repetition, and improve the readability of our codes, which are very important, especially for big size program. So in Python, we can categorize the function in 3 main categories. We have the first one, which is the type of the building function. So Python provide in its standard library a bunch of building function that we have already used some of them, such as print, int, sum, you name it. We have a bunch of functions that are available in the standard library of Python. So these built-in functions are always available. When you load the Python interpreter in memory, automatically these built-in functions are also loaded in memory. The second type of function are the function which are defined in the built-in module. Okay, the Python library provides several modules that are used to define a group of functions together. Okay. In contrast to the previous type of built-in function, module-defined functions are not available at the moment you load the Python interpreter in the memory. They have to be imported in memory for you to use them. To import the function defined built-in function or the module defined built-in function, so you have to use the keyword import to import the function in your program, so you can be able to use that. So these two categories of functions are provided by the Python software as a library. So let's assume that you would like to implement your custom function. So Python gives that possibility to define your user-defined function to make your own function that will implement your business logic for you to use that business logic in your program. So in terms of library of library of built-in functions and module in Python, they contain several functions, okay, which are organized in terms of services, okay. Like you have the module which is implementing mostly use mathematical functions which are defined in the math module. You have also statistics functions which are defined in the statistics module. You have also operating system related functions that are implemented in the OS module. You have also time-related functions. They can also be provided inside each module, math, statistics, OS, you name it. You have a bunch of modules that provide additional functions that are commonly used. So for you to use the functions that are implemented in the module, I've mentioned that earlier, you have to import them first. And then the import of module function has to be preceded by the prefix module of the name of the module. Like you can see here, you have the module name and then the function which is implemented inside that module. Math, sqrt, which is a square function you can call and then provide a parameter. To learn more about the list of Python supported or provided built-in function and module defined built-in function, you can check the Python documentation that provide all related information for you to know that. So I've provided in this slide a list of commonly Python built-in function, which include some of them we already use them, such as prints, which help us to print or display the outputs of any operation or any value of a variable. You have inputs function, which is a method or function. When I say method or function, method are just conceptually concept used for function. Okay, so they can be used interchangeably. So functions such as inputs, they help us to get user inputs. Length, for example, it's return the length of a sequence of characters or objects. Like you can see here, you have length, which take as a parameter a sequence of character, and then it can give us the length of that string character. Function type, it's return the type of the variable. We have used that. You have int that convert in integer. Floats convert given value in a float or decimal point value. You have str, which is used to convert a value, a given value into a string representation. You have sum, which adds item in a sequence, like you can see in this example. You have a sequence of numbers which has been given as a parameter to sum, and then the sum function will output the sum of all the item within that sequence. You have max function, which return the maximum value of a sequence of values. Like you can see here in this example, you have a sequence of value, and the max function can only return a single value, which will be the maximum value from the list. Opposite to the max, you have min, that return the minimum value. You have also ABS. ABS return the absolute value of a given number. Let's say if you give a negative value, it can only return the absolute value of that given value. You have also round. Round also is a function which rounds a number. Okay, if you have a given decimal point number, like here 3.456, the round basically receives at least two parameters. So the first parameter is the value that needs to be rounded, and then the second value is the second parameter is the number of digits that need to be considered while rounding. Like here, you have this decimal point value, and then you use 2 as a number of digits after the decimal point. That means it will round the number considering 2 digits after the decimal points. Sorted is a function that return a sorted list of items, like here. It's dependent on what you are looking for. You can choose among these building functions to build your own logic. There is one more building function which we have already used with for loop, is range, that generates a range of numbers. Okay, and then you have the bool. Bool is the function that is used to convert any given value into a Boolean type. So here is the list of commonly used built-in function in Python. Just to give you a sense of what I've mentioned, how can we use this function I've mentioned earlier? Let's take functions that print the output we have seen, like prints, and then we have other functions that help us to convert a given integer number value into a different representation, like binary, octal, or hexadecimal representation. Like in this line, we have value, which is a variable initialized with an integer value, which is 65. And then using bin function, we convert the 65 integer value within the binary representation. Then we use the print function to print the results that will be represented as you can see in the comment line. Oct also take the same integer value, and then it's converted into the octal representation, which will be like that. And then you have also X, which is using a given value, and then it's converted into hexadecimal representation as shown here. Same for the CHR, which is it take a value and then represent it as a character like that. So this is the way we use those built-in functions. In the other case, I have explained how to use the round, which will take a decimal point number, like it is shown in the screen. And then we have the first parameter is the value that needs to be rounded. The value here will come from this variable, which is value that is used to store this decimal point number. And then we want to round it with 1 digit after the decimal points. So the result will be like this 1234.6. You can also use formats to represent the value of the output. You can format that. Like here, I would like to print this value stored in the value variable as a number which will have 2 digits. So for you to represent or format value according to this standard, you have to use the format function and then define how many digits need to be formatted after the decimal point. I've mentioned earlier that we have many modules in the Python standard library. I would like to elaborate on the math module, which include a variety of mathematical constant and function, such as the root square, or the trigonometric calculation, logarithmic function, and more. So for us to use these math module define building function, we have to import them. To import them, yes, the syntax, you use the keyword import and then the name of the module. So wherever you would like to use a module define building function, you have to call first the name of the module, and then you can specify which function you would like to use. So here is an example that shows how we can calculate the area of a circle. As we know, for us to calculate the area of the circle, we need to use a constant value, which is pi. Okay. Before, we have to import the math module, and then we need to collect the value from the user. That means we need a variable which will be called r, that will represent the radius value of the circle for which we are going to compute the area. And then this radius value is casted as a float type. That means it can be integer or decimal point value. Then we use input function to collect the value from the user. In order to interact with the user, we provide a prompt text in the input function as a parameter that can be shown to the user, so the user will know what to do. Then, as soon as we collect that value, we store the value within this variable r, and then after getting that value, we'll run the next instruction to calculate the area. The area of the circle basically needs to be computed considering the pi value, which is a constant. The pi value is equal to 3.14. So we already know that value. But since it's a commonly known value within the math library, that's why we call the pi constants, which is defined in the math module. So first of all, if we use this syntax without defining this line by importing the math, it will not work. So as long as we already imported the math module, we can use that. So here we can collect the value of the pi, which is defined as a constant, into the math module. Then we will multiply by the power of the radius. That means the square. The power of the radius that will be elevated to the power of 2. That's why we use here power function that will calculate the r to the power of 2. So without any difficulty, this will be easily understood by the interpreter. Then the following line, we are formatting the way the Python interpreter should show the result by prompting the message like area of circle, and then we can print the value of the area by rounding, considering 2 digits after the decimal points. So here's the code. For example, here when I run this code here, is the same. When I run it, you will see it is asking me to provide the value of the radius. Let's say I provide the radius, which is equal 125.6 with 3 decimal points. And then you will see here the result will be shown as area of circle. Here's the result, and then with 2 digits decimal value. Okay, so because I formatted that, considering the rounds function, that will be rounding the decimal points, considering the second digits of the decimal parts. So with this math module, we can reuse mostly common mathematical functions as well as scientific computing functions, such as geometry related functions can be also retrieved from the math module, or some commonly financial computation operation also can found the function which are implemented in this module. To get more insight about this math module, just refer to the Python documentation that will provide the complete list of all the functions which are implemented in that module. So here's the lists of commonly used math function, such as the SQRT, which is returning the square roots of x. And then on the right side, you have the syntax of using the math related functions and the expected result that can be received from the given input parameter. You have pow, which is returning the x, okay, value raised to the power of y, okay. It says to get at least 2 parameters. You have the floor, it's returning the largest integer less than or equal to x, which is given as a parameter. You have this ceil, it returns the smallest integer greater than or equal to x, which is given as a parameter. And then you have fabs, it's returning the absolute value of x, okay. The factorial is the function which is returning the factorial of n. It's only accepting non-negative integers. We have GCD that receives 2 parameters, 2 values, and then it will return the greatest common divisor of a and b, which are given as a parameter. You have the LCM, which stands for last common multiple. This function will return the least common multiple of a and b. And then you have the is QRT that will return the integer square roots of x, which is given as a input parameter. So for the LCD, it has been introduced in Python version 3.9 and plus, while the is QRT was introduced in Python 3.8 and plus. I have mentioned earlier, we have also other functions such as logarithmic function, which are included into the math module. For commonly used logarithmic function and the expression, I have provided a summary in this table, like this x, which is a math module defined built-in function, return the e raised to the power of x, okay, as a logarithmic operation. You have also log x that will be returning the natural log base e of x. And it can be used like this, math dots log, and then you provide the value that's for which we are going to calculate the natural log. And then you have log 10 that will return the log base 10 of x, which is given as a parameter. And then log 2 will return the log base 2 of x. Here are a few commonly used logarithmic functions. The list is not extensive, so you can refer to the Python documentation to get the extensive list of the logarithmic function. We have also trigonometric functions, which are also provided in the math module. That, for example, can be used to convert radius, okay, degree in degree and degree in radius. Like sine function is used to compute the sine of x in the radius. And then here's an example. You have math dot sin sine, and then you provide the value for which you would like to calculate the sine. In this example, we want to calculate the sine of the constant pi value divided by 2. And then you have cos function compute the cosine of x, which is given as parameter. Then compute the tangent of x, which is given as a parameter. In this example, we have tan, which is used to compute the tangent of the constant pi divided by 4, which is 1. And then you have degrees function defined in the math module. It converts radians into degree. And then you have radians, it converts degree into radians. So those are trigonometric functions that are defined into the math module. Again, the list is not extensive. To get the extensive list, refer to the Python documentation. Above that, we have other rounding and modulo related function, like in the previous examples, I used just round and format function to truncates the decimal points by defining the number of the digits that need to be reused after the decimal points. You can also use the trunc function, which concatenates by removing the decimal parts, okay, of float number with a decimal point value. For example, in this example, I have 5.9. So using the trunc function, it can only return the integer part of the number. Here we have also a function which is modef. Modef is returning the fractional and integer part of the x, which is given as a parameter. You can see here is the example. And then you have copy sign that receives two parameters, x and y. It's return x with the sign of y. Like here in this example, we have two parameters, x is equal to 3 and y is equal to -1. And then the result of this instruction will give -3. Okay. Other details that are implemented in the math module are constants. Okay, like we have seen, pi is the constant which is universally known. We have the e, which is the Euler's number for natural logarithmic base, which is equal to 2.71. You have the torque, which is the constants for circle is equal to 2 pi. You have fin in, which is a positive infinity. And then you have none that represent a not number. So here are the constants that are defined in the math module. The list is not extensive. You can refer to the Python documentation. So far, I've covered the two types of Python functions. The built-in functions, which are the type of function that are already available in the Python interpreter at the moment you load the Python module or program in memory. The second type I've discussed is the module-defined built-in function in Python. These type of functions are not available at the runtime, but you have to import them using the keyword import and the name of the module you would like to import. To get more details about those two types of functions, you have to refer to the Python documentation, official documentation, to get more insight about that. Now, I will be elaborating on the third type of the Python, which are the user-defined Python function. So if you would like to implement your own logic in your functions, now be careful and follow me in this second part of this lesson, where I will elaborate how should be defined such kind of functions and which kind of parameters can be passed to such kind of functions. In terms of syntax of user-defined function in Python, the definition of a function starts with the keyword def, okay, which is the keyword used to define a function, followed by the name of the function. To name the function, remember the ID rules we have seen for variables and any object that can be used in Python. We have several ways to make or design the name of function. We have the camel approach. We have also the rule that says that an ID can start with letter and can include letters or numbers, but cannot include special characters except the underscore. So follow the same rules, and remember that a name of a function should be unique. Okay, and then the name of the function will be followed by parentheses. Okay, the parentheses will be receiving the parameters that will be passed to the function, and then the header of the function definition will end with the column that say that this is a kind of multiple line instructions that will go behind a single physical line. So we'll have several physical lines that will be implementing this instruction. Then on the second line, this is optional. You can provide the function docstring. What is the role of this line? You can just provide a small explanation on the purpose of the function. This is optional. You don't have to do it all the time. Then will be followed the body of the function that implement the statement, the group of statements or a single statement that will be performing the function. Then optional also, a function can return the result of an expression or a value to the environment that has called the function. In some cases, if you don't return anything, in that case, there is no argument, so the return is none. So that's why I mentioned that is optional. So this is a typical function definition syntax. So we'll see now what could be some examples to illustrate that. For the definition of the function by the user, remember that by default, parameters that are provided in parentheses, they have positional behavior in the function. So be informed that you have to send them in the same order as they have been defined, okay, in the function. Once the function is defined, you can also call or invoke the function by using its name, and then the function will perform the logic which has been implemented inside the function, and then it will return the result if that has been defined. So here is an example that shows how we can define and call a function. The function here in this example will be named greeting. So this function will be a greeting by showing the message hello world. You remember the first instruction or the first program we have implemented in this class was to print the hello world message. It was just this instruction. So we can also combine that instruction, define that within a function that will be greeting. So whenever we call the function will be showing the message hello world. So here the function is defined by the keyword def, followed by the name of the function that is greetings, and then we have parentheses. Here parentheses are empty. That means this function do not receive any parameter. And then we have column that say everything following the column will be indented. Okay, you will see here we have indentation showing that the body of the function should be inside the function. And then we have the second line, which is the string doc that provide a quick summary of the function specification. This function is a greeting function. And then here you have the statement or the instruction that will be performed by the function is to print the message hello world. So to use this function, we have just to call the function in the body of the program. You can see greeting is not inside the function, is at the same level as def. That means it is the line that is used to call the function, and the output will be hello world. So remember that when the parentheses are empty, nothing is given as a parameter to the function, and the function is always called by its own name. So I can show you how it works. You have the script I've explained to call the function. I'm using this line here where I call the function by using its name followed by the parentheses. But remember that when you call a function, you don't have to put the column at the end. The column is just for defining the function, saying that is a multiple line instruction. So when you call a function, just use the name that will be followed by parentheses. If you have to send parameters while calling the function, you can put them inside the function. When I run this instruction, you will see it shows the message hello world. Quite simple, right? Then when we define a function, we can specify a list of variables or values that can be passed to the function. These are called or known as formal parameters. Okay, they are always within the parentheses following the name of the function. So these parameters, they act as a placeholders. They are just variables that are defined to receive the values that will be passed to the function when the function will be called. So when the function is called, we send the values. Remember, I mentioned that these parameters, they have a positional behavior. So you have to provide the values following the order you have defined the function. So the value you send to the function that will be mapped with the formal parameters, they are called actual arguments, okay, because they can change. They can change depending on the situation, depending on the input you are sending to the function. So the function parameter or arguments are values inside the function, okay, parentheses, when the function is called. And then they are also influencing the behavior of the function. So like here, you have a function 1, which has to receive 2 arguments like this, 1 and 2, and then should return probably a result. When you call the function, you have to pass the value 1 and 2 that will be mapped like this. Value 1 will be mapped with arg1, and value 2 will be mapped with the formal parameter arg2 that has been defined in a function. So let's see that with an example. The previous example, we have defined the greeting function. So within the greeting function now, let's pass a parameter. So instead of just fixing the program to show hello world, let's make it dynamic. So whatever value we can pass, it can say hello, followed by the name. So here we define the function, and then we define a parameter, a formal parameter, which will be the variable name. The doc string explain just what does the function. It's just a greeting function, and then the statement here is print hello with the name that will be passed to the function. It doesn't return anything. That means it's have a non value, which is returned to the calling environment. The calling environment here is the main program where we use the function. Here is the function definition, and here is the call. This one is the function definition, and the number 2 is the body of the program that call the function to use the logic or the code implemented in the function. So whenever we call this greeting by passing a value, like here we are passing a string value Alice, it will show hello Alice. If we pass Bob, it will print hello Bob. If we pass the value Malek, it will print hello Malek. When I run this script, you will see it will print 3 different lines: hello Alice, hello Bob, and hello Malek. This is the case of a function which receive values which are passed as an argument that will be mapped with the formal parameter name, which is defined within the function parentheses. Okay. Here are a few types of function arguments that are supported by the Python functions. So based on the type of the parameter or argument you send, this will be affecting the behavior of a function. So we have 6 main types of arguments that can be passed to the function. The first one is the positional or required arguments. Okay, and then the second one is the keyword arguments. The third type is default arguments, and then the fourth is positional only arguments. Then we have the keyword only arguments. Last but not the least, we have arbitrary or variable length arguments. Depending on your situation, if you know exactly how many parameters you have to provide for the function, you can fix that. If you don't know, you can use a dynamic approach using arbitrary or variable length of arguments. Let me now elaborate on each of these types of arguments that are accepted in the Python programming language. The first one is the positional or required arguments. So these are arguments that are passed to the function in a correct positional order. If you just shift them, if the types are not compatible, it will not accept the values you are sending to the function. So the number of arguments in the function which use positional or required arguments should match exactly the number of arguments that has been defined while declaring the function. Otherwise, the Python interpreter will raise errors. Like here, in the previous example, we have provided the official arguments, which is defined as a formal parameter in the function that will be receiving one parameter name. But when we call the function, we do not provide any value, okay, which is passed as a parameter. This will probably raise an error, okay, because the Python interpreter is expecting to get any value for the function to run properly, but you don't provide any value, so it will raise error. So it will be like this kind of error. Trace back most recent call, and then it will find out, okay, there is nothing which has been provided because it's expecting to get at least one argument. So let me show you here. You have that example. When I run it, you see it raised type error. Okay, is expecting to get a parameter, but you didn't provide. You see, the interpreter is telling me that there is a missing positional argument that need to be provided, and it will be mapped with the official parameter, which is called name. So to fix that, you have to provide at least a value. Okay, you have to provide at least a value like this. In the following example, here you have a Merlek, which is given as a value. Then the issue will not raise again. The second type of arguments is the keyword argument type, okay, which is related to the function call, okay, that need to be identified using the parameter's name, okay. So this this approach allows you to skip arguments or place them without the order. So this is the particularity of this keyword arguments, because the interpreter will just use the keyword specified for each variable to match the parameters. Like here, you have a function which is expecting to receive two parameters. Like one is named name, and then the second one is age. So while calling the function, although you shift the order, it will not make an issue, because the function will be mapped the parameters based on the name. Like here, when I call the function, I provide age as the first parameter, which is sent, first argument, which is sent to the function, and then it will be mapped with the corresponding variable. And then Alice will be mapped with the corresponding variable like this. With the example here, when I run this script, you see it's gives me name Alice and then age 20. So regardless of the position of the argument I'm sending to the parameters of the function, it will map them using the name of each of them to receive the value. This is the second type of arguments. The third one is the default argument. The default argument is the type of argument that assume a default value. If you do not provide any value, it will assume to consider the default value that has been defined. For example, here, with the same example we have seen earlier, I just fix the age, which take 20 as a default value. If I call the function without providing age value, it will work, and then it will assume that the value is equal to 20. But if I call this function by providing the age without name, it will raise an error, because the name should be provided. Otherwise, it will say that there is an argument which is missing. But although for the age, I can provide the value or not in case the value does not fit the default value. Like here in the second call, I provide 25. That means Bob does not have 20 as age. Bob has 25. That's why for Alice, by default, Alice match the default value. I just call the function by providing only the name. Here, when I call, you will see for Alice, it will show Alice 20. And then for Bob, it will show Bob 25. Okay, let me show you the case I've just explained here. I will just reuse the same code like this. But in this case, I will just provide, I will comment this one. Let's say I just provide, let's say I just call the function without any parameter. It shows me like I miss only one value. So name should be always provided. So this is just a particular case I wanted to mention just to give a sense to what I've explained earlier. The next category of arguments is the positional only arguments. With the positional only arguments, we specify the position of the arguments that will be sent to the function when it will be called. For this, basically, we define by placing this slash in the function parameter for all positional only parameters. Okay, so this feature has been introduced in Python 3.8. In this example, for example, you can see x, y keyword parameters, but this one after this slash, all the parameter coming after slash will be considered as a positional only arguments. Like in this function, we have the function call, which receive 3 parameters. 25 will be mapped with x, 30 will be mapped with y, and then this z will be the positional argument that will be sent to the z parameter. Then when I run this, you will see it will take x, y, and z, and then it will give back the result of the expression that sum x plus y and z, which will be 70. So this is a particular case for the positional arguments. But the benefit of using a positional argument is to ensure that the function is called with the correct arguments, okay, in the correct order. And this should be also passed to the function according to the position of each argument, okay, not keyword. Just respect the order, otherwise it will not let's say run the correct logic you are intending to implement. The fifth is the keyword only arguments. In this case, we have arguments that must be specified by the name, okay, and then when we call the function, we will use the variable argument that will be sent, but they have been defined by placing this asterisk, okay, the star in the function parameter before to specify that it's a list of keyword only parameters. So this type of arguments can only be passed to the function as a keyword argument, not as a positional arguments. So be aware of that. In this case, I've reused this previous example where I pass the arguments as positional arguments, but here I will pass them as keyword arguments. You see here, I put a star, and all the parameters following star will be mapped as they are provided to the related keywords. So here, when I send the argument value, I use the parameters variables name, like x will be taking the value of 5, y will be taking the value of 6, and z will be taking the value of 10. So they will be received. Here I will have 5, and then in here I will take 5, and then here I'll take 6, and then 10. Then I will produce the result of 5 multiplied by 6 multiplied by 10. That will be the result that will be sent by the function. So let me see how the result will be shown for this function. When I run this script, you will see the product of x multiplied by y and z will give us 300. For 5 multiplied by 6 by 10, it will give 300. And the last one is the type of arbitrary or variable length argument. So in this case, you need to process a function for an unknown number, okay, of arguments. If you have more than one argument and you don't know exactly the number of arguments, you can use this case. where you can just specify in the function an arbitrary number of parameters that can be passed as an argument. So these arguments are called variable length arguments. Okay, variable length arguments, and then they are not named in the function definition, unlike to all other type we have discussed. And the syntax for non-keyword variable arguments, which are unknown, you can just use the same definition, name def, name of the function, and then inside the parentheses you can just use the star, and then you use the name of variable or the name of the tuple or lists, any object that can use a collection of values. Then you have the docstring line that will provide explanation of the function specification, and then the body of the function, and then the return expression value, or which is optional. So this star, as I mentioned, is just a plus order before the name of the variables. So here is an example that shows how we can use the variable length argument. Like in this case, the function name is printinfo, and the printinfo receive arg1 parameter, and which should be of tuple. Okay, that neither it should be a collection of values. And then I have this docstring line. If the docstring line is only a single line, you can just use double quotes or single quotes. If you have it on multiple lines, you use triple quotes. And the function body here will print output is, and then we'll print the argument 1, and then we'll loop inside the var tuple to show all the elements of that collection as provided. So as you can see, this is kind of arbitrary. I can call this function just send one value or several values. Here, when I call the function, I just send 20. It will work. It will only map this 20 with this arg1. And then when I send several values as a collection, it will also work. So let's see the working of this example. When I run it, look. When I run this, you will see when I send just a single value, it works, it provides the output without running this for loop. But when I send several lines, several values, it will also run the loops here to read all the items in the collection of var tuple. So this is a particular case, especially if you are not aware of the number of values that can be passed. You can just hold the space and provide a kind of collection variable type that can take several types of or several values. So to summarize on the Python function argument and the order, here I've provided how the argument must be declared within the Python function. Here's the order to follow. When you define the function with def and function name, in the parentheses, you can define a bunch of arguments as official parameters. The first one type is the positional only parameter. Okay. And then you have this that shows that they are the positional only parameters. And then will be followed by the regular ones. After the regular ones, you have the default arguments where you define the default value. And then you have arbitrary positional parameters where you put the star. And in some cases, okay, you can have a keyword only. You can define them as I've shown here. And then you have also arbitrary KW arguments that has to take star KW arg. Okay, so I've provided all the explanation. For the last one, arbitrary KW arguments, you put star saying that it accepts arbitrary number of keyword arguments. So this is what you have to keep in your mind when you define your own functions that take arguments that has to be mapped with the formal parameters. And then a function can return a value. When a function is defined to return a value, The value can be the result of an expression, as I've demonstrated in the previous example, or it can be a value coming from a variable. If it doesn't return anything, that means the return is none. We have also seen that. In this example, for example, you can see this function try to perform the addition of two given parameters x and y. So that will be assigned to z as the holding of the result of x plus y. And then it will return the value of z. Then later, the function is called in the main program that has initialized a to 10 and b to 20. Remember, I've mentioned if you have to use several instructions in one line, you can separate them by semicolon. Okay. And then you have the results. The results of the addition should be stored in a variable called result. Then, in order to do a plus b, we call the function add. We pass the value inside a and b. I will explain now. You can see here, a will be mapped with x and b will be mapped with y. So after this, I will explain now the scope of variable. We can have variable which have limited scope. So although here the variable that's called add function, it has another name, but what is going on here, it will just transfer the value inside this variable to that formal parameter that has been defined in the function add. And then the print formatting is like we print A as a text, and then we have a plus order using those brackets, B equal plus order, and then we use format function. So the format function will be formatting the results that will be printed according to the position. So the first plus order will take the value of I, the B will go here, and then the last one will be at the third position. So this is what does the formatting function. So I will show you how does this code work. You will see here, it will show the result like A equal 10 and then B equal 20. So value of A, 10, was passed to X, and then 20 inside B was passed to Y. I would like to show you with the Python visualizer. Python visualization. Okay. What is that one again? I think, yeah, yes, the first option. And then I will just take this code and then show you at the runtime what is going on. I will make it big so you can see. Okay, when I click on run, I can visualize what is going on. You can see at the beginning, the interpreter will be pointing on the first line of the script, which is def. Okay, it's basically acknowledge the definition of the function. And then when I click next, you can see directly it goes to the body of the program, because by pointing on the first line, it will acknowledge the structure of the function. That means it knows directly that this function here, you can see, is an object that will be receiving two values, x and y. Then now I will run this line 6. When I run this line, you will see I have two values that have been stored in memory. A is the address that is used to store this value, 10, and B is the label which is used to store in memory this value, 20. Then now with this line number 7, I have an instruction. Okay, that's called the function add, and then we'll take the result of the function add that need to be stored in the results. When I hit on next, look at here, I have the call of this function add. Okay, and then inside x I send 10, and then inside the y I send 20. Then I will go back to line number 1 to run the function. You see red. Okay, when I click on next, you will see I can now run the second line, which is the first instruction inside the function. And then next, you will see I have the result of x plus y, which is stored in z, 30. And then line number 3, the instruction is to return the result of x plus y, which is stored in z, to the line that is called the function. Next, you will see return value. which value? 30. Here, I will return 30, where directly the return will be referring to line 7, where the function was called. When I click next, you will see here the result will be sent to results in memory. And then the line number 8 will be executed. I have the output here. I hope it's clear with the execution of the function and the passing of the parameter. Next is another example that return basically the power of the value given in the parameter is the square. So in this example, I define square function. This is a custom defined function. It's not the building function we have seen, the SQRT. This is the user defined. What does this function? It's return x multiplied by x. For the return expression, you can use parentheses or not. It's okay. Okay. But for clarity, it's better to use parentheses. Although if you don't use parentheses, it's okay. And then in the main program, I use this statement to call the square function with a parameter, which is send the value of 4 as an argument. And then the result will be stored in a result. Then I will print it. Here, when I run, the output is 16, which will be x multiplied by x. So here you have a complex, let's say the review of all the cases I've discussed so far. In the first function, you can see I have empty arguments which are sent to the function 1. The function 2 as parameter, just a single parameter that is to be sent, and then it shows the message that need to be combined with the value inside the parameter. And then the function 3, you have also the function that receive a parameter and return the results to the calling line. Okay, that will double the value inside parameter. So for calling the function 1, I have to call just the name without without sending any parameter. For the function 2, I have to send the parameter. If I don't send, it will raise an error. For function 3 as well, I need to make the statements that will use the result that will be returned. You can see 1 and 2, I don't have to use the statement because it doesn't return any result. But if you are collecting the result from the function, make sure whether you print the results. If you print the result, you don't have the value of the result in the main program. If you would like to use the value sent by the function as a result in the main program, you have to keep it in a variable. This line is very important. Okay, and then you can use that within other instruction like prints to print the results. When I run this code, you will see the first call will just show the message in function 1. Second call here, function 2, it will just print the message in function 2 with parameter value. The value is test. And then this call here, it will show this message in function 3 with value tests, and then it will print this line with function 3 return test. Then remember that you have 2 sections, okay, with the code when you use functions. You have the definition functions, the definition of the function. That section has to be defined before the use of the function, okay? And then you have the body where you use the function by calling, by using the name. So respect that, let's say, definition, and then the use should be always whether inside the function. If you use a function inside a function, make sure that function has been defined earlier. I've shown how that works. Another case here is where you define a function and then you provide hints about the types of variables. Okay, let's say here I casted the value, the types of values that will be received as an argument. Like here I have a def add function that will receive 2 parameters. The first parameter is num1, that should be of type int. And then num2 should be of type int. Look at now here. This means this function is expecting to return an integer value. This is the meaning of this part. That means you cast the type of the result that need to be returned to the calling statements. Then you have here the string doc line. So this function will take the value that will be sent through the parameter num1 and num2, and the sum will be stored in num3. Then num3 will be sent back to the calling line, which is here. Remember, this num3 should be of type ints. And then the driver of this code is the main program where we call the function. Here we have the first line that initialize variable 1 and 2 with the value 5 and 15. This will go in 1 and this one will go in 2. And then we pass the value inside num1 and num2 to the function add. It will call this line. It will go to that line, and then it will compute this line, will return this value. Basically, it should be returned here. Here I mistaken the name of the variable. It should be num3. Not that one. This should be num3. Please correct that in your notes. This should be num3, where we pass the values. And then the result will be addition of 5 and 15 equal 20. So in this example, we have seen how we can cast the type of parameters that will be sent to the function and the value that will be returned to the calling body. So here we use the name of the variable and the type, the second variable name and the type, and then this is used to determine or casting the type of the value that need to be sent back to the calling instruction. And then here we call the function add with two values that will be coming from num1 and num2. In num1, we have 5, which has been stored, and the 15, which has been stored in num2. Then the result that will be sent back to the main program will be from this line that will send the result, which will be stored in this ans variable, and then we format the printing saying addition of num1, which is 5, and 15 is equal to ans. That will be 5, 15, and then the result will be 20. So now I will be explaining a particular case of function is the anonymous function. In some cases, when we use anonymous function, which are not declared as a standard function using def, such kind of functions are called lambda function. So lambda functions are declared with the keyword lambda. So the syntax of declaring a lambda function is to use lambda keyword, and then you provide the arguments that need to be given to the lambda function, and then the header of the lambda function always, or as other instruction, will be followed by the column, and then will be the expression that will be executed using the argument that will be given as values. So in this case, lambda is used to define an anonymous function. This function does not have a particular name as we have defined in other types. So what are the characteristics of a lambda function? A lambda function can take any number of arguments, but always return just one value. Okay, that can be from a variable or from an expression. And then a lambda function cannot contain comment or multiple expressions. So it's just one line function. So you don't have to define multiple comments or multiple expression in a lambda function, as we have seen for normal functions. And a lambda function is anonymous. That means cannot be called to print, let's say, a result or from an expression or whatever. So a lambda function also has its own local namespace, okay, and then cannot access variable other than what have been sent from the global namespace. I will explain what does global namespace mean, local namespace mean later. So what you have to remember is that a lambda function is a type of a function which does not have a specific name, okay, but it is defined by lambda keyword. And a lambda function cannot include multiple instructions, okay, or expressions. So the lambda function, okay, is only one line version function. You have only a single line where you define the logic of the computation you'd like to do with that lambda function. This kind of instructions are not available or equivalent to the statements which are provided in C or C++. So this is just a particular case of implementing anonymous function which provide the Python programming language. I will try to make sense of the concept of lambda with an example. Let's say, okay, we have a function we would like to define, a function that we like to define within one line that has to provide the sum of two arguments. So we have here the variable that will be taking the results of the lambda function, and then we use keyword lambda with the list of arguments that are sent, argument 1 and argument 2. Column, after column, we have to provide the expression that need to be executed, okay? So the expression will be argument 1 plus argument 2, and then we send back the result to the lambda calling statements which will be affecting the result of this expression to the variable sum. So in this case, we can only use the value of the lambda function, which is stored in sum. But we cannot call a lambda function because it doesn't have a name. So here later we can just call the sum, okay, like a function, okay, because sum here is lambda function, and then we provide the argument values 10 and 20. So in sum, the interpreter will understand like sum will receive two parameters that will be sent to the lambda, okay, function, and 10 will be mapped to argument 1, 20 will be mapped to argument 2. And then the print will print the results of that lambda function execution. That will be 30, okay? And then the second line, send the same value, 2020 for argument 1 and argument 2. So the second print will print value of total. So when we check the execution of this logic, you will see here when I run, you have the expected outputs, which is value of total 30, value of total 40. So this is a particular case of a function, okay, which are possible in Python programming language. So I've mentioned earlier that the lambda function has to take the name within the local namespace. It has a local namespace, and it doesn't access to the parameters from the global namespace. What does it mean exactly? So I will now elaborate on that by explaining what we call scope of variables when we deal with functions, because functions are totally independent block of code which are called by other functions or in the main program, but they operate independently depending only on the argument which are sent to them as values. So what will be now the scope of variables used inside a function and the variables which are used in the main program? You remember in the previous example, there were cases where in the main program, I defined the variables A and B that were passed to the function and mapped with the formal parameters that were defined as X and Y. So now let's see the scope. So mostly when we deal with function, all variables in a program may not be accessible, okay, at all location in the program. When we are in a function, some variable cannot be accessible from the function. So this depends on where you have declared and initialized the variables. So the scope of a variable in Python is defined as the specific area or region where the variable is accessible to other users or other part of the program. So the scope of a variable determines the position, okay, or the portion of the program where you can access a particular identifier for an object that can be a name of a variable. So we have in Python three basic scopes of variable. The first one is the local variable, and then the global variable. The other one is the non-local variable. So the local variable is defined basically by the inside function of the body. So the local variable can only be accessible if you define a variable inside the function. You can only access to the value of those variables inside the function. That's the scope of local variable. But the global variable are defined outside, okay, and they're accessible to the entire program or script. The third one is the non-local variable. For the non-local variable in Python, so there are variables which are not defined either in the local or in the global scope. I will now elaborate more in detail for each type. As I mentioned earlier, the local variables are accessible only inside the function, okay, the block where you have defined the variable, and the scope is very limited. So in this example, we have my function, which is defined. My function does not receive any arguments because there is no there's not any formally defined parameter. But inside the function, we have a and b, which are local variables. They are only known by my function. Outside my function, if you use a or b, the interpreter will not be able to identify them. And then a and b, they are declared and initialized with the initial values 10 and 20. Then you print the variable a value using prints, and then variable b using b. Then you return the sum of a plus b to the calling line. So the calling line here is prints my function. You call my function, and then it will return a plus b. That will be 30. This is the illustration of local variable in Python. When I run this, you can see it's work properly by showing the results of the function which return the value of a, b, and their sum. Okay, let's take an example to illustrate this with the same. Now here, I would like to use the same print variable a and b, but outside of the function, okay? Just after print function call. So with this example, when I run this newly modified code, you will see in this case, a and b has already been loaded in memory. So that's why it's try to find the value in the global namespace. That's why it finds the value of b, a and b outside of the scope. But let's assume before I run this, okay, let's say I change. Let me change, for example, here x and y, because I've never run with these two new variables. You will see I wanna illustrate what I've mentioned earlier. I have x and y. This time, I would like to change a little bit. Put those two lines before the prints. Before the main program acknowledge the existence of x and y. When I run this, you will see it doesn't know what is x, what is y, because they are not in the scope of the main program. They are not global variables. They have been initialized inside here for them to be created in the working environment. But when we use them, they're still not created. You can see if I just change the location, call the function first, They will be created in the space, and then they can be used. So this is the illustration of the scope of variable. So the second type is the global variable. So the type of global variable can be accessible from everywhere. If I've defined a variable inside the main program, but I can still use it even in the function because they share the memory space. And then it is defined inside the body of the program, and then outside of the function, the variable which is defined outside can be used inside the function. That means it's a global variable. It's not specified in any block of the function. In this case, I have cost, which is a variable that is used to store this string text value, and then the course, and then score. You have the score, which is stored in the variable 19, and then we have the function definition. Inside the function definition, we can use course and score because course and score have been defined as a global variable in the global memory space. So when I call this function, automatically this function will be able to retrieve the value of course and score that will be passed to the function, and then the function will print them because they are in the global memory space. I will show that with the example here. So when I run this, you will see it shows the contents of course and scope. Okay, because this print instruction is executed to call the function after these two variables has been created in memory. Since the function share the same global memory with the this print line, it will be able to access to the value which has been stored in memory. But the reverse is not possible. When variables are defined inside the function, they cannot be accessible outside before they have been created in memory. Keep that in mind. With another example here, we have the combination of local and global variables. Results is a global variable which has been defined and initialized with the value 0. We have the function definition, add x and y. X and y, they are local variables which have been defined inside the function. And then you have a and b, they are global variables because they are defined outside the function. When I call add here, sending the value inside a and b, which are global variable because they have been defined and initialized in the global memory, this a and b can be sent to y and x like this. Then the result will be sent and assigned to the result variable. Results will be updated with the value which will be returned from this line. When I check this code, you will see it's work properly. I don't know, you have noticed something like non-value in the previous example. So this will lead to the non-local variable type of variable. So non-local variable type in Python are not defined whether in local or global space. They are called non-local variables. So they are used instead of functions because they are declared naturally as a non-local variable using the non-local keyword. Like in this example, we have your function, which is a function which is defined. It doesn't take any formally defined parameter. And we have local variables here, a and b, which are defined. And we have inside a function, we have another function. From my function, a and b are global variables because they share the same memory space. But non-local variable a and b values are different from the one defined here in the your function. And then, okay, here again, we have a and b, which are initialized because a and b, in terms of memory, they can have the same, the common address. So inside here, a and b, this value will be overrides. We will not have 5 and 6, we'll have 10 and 20 because they share the same value. When we print a and b, we'll have 10 and 20 because they have been updated in memory. Then the main program, when we call your function will initialize a and b as a global variable from your function perspective and my function. And then inside my function, we have also non-local variable. This is the way we can illustrate that. Let me show you with this example. When I run this program, you will see now A and B has been updated as 10 and 20. Then the sum is 30. So this is an illustration of how we can use these three types of variables. Global variables are accessible everywhere in the Python script or program. Local variables are only accessible on the scope of the block of code which they are defined. And you have also non-local variables which are not global or local. They are defined with the keyword local, non-local, followed by the name of the variables. I hope it's clear. They are very important notion. With that said, let me clarify now the concept of namespace and scope in Python. So the namespace is basically the collection of identifiers, okay, which we use for variable names, functions, classes, any object we are creating in our programming environment. They share a namespace. You remember we have seen the rules to follow to when we make the name or ID of variables or any objects. So that means they share the domain namespace. And then in Python, the namespace is used to manage the scope, okay, of variable and prevent the naming conflicts. You remember I still mentioning that any identifier for whether is a variable, a function, they should be unique. That means we have to prevent conflicts. That's why we do separate the local and global namespace. In terms of scope, we have first the built-in namespace. Okay, in the built-in namespace, we can find most of the keywords we have seen. Okay, in the introduction, when we make names as ID for our variables or function, there shouldn't be any of the building reserved keywords. You remember I mentioned that. So those keywords belong to the building namespace. So you don't have to use any of the name from the building namespace. Then we have the global space. The global namespace, okay, is where you define the name of any object, whether it's a variable, whether it's a class, whether it's a function. You define in a global space. That means from the scope of your program. Then you have local namespace is restricted to the block of code like function where they can be used. This is the relationship between the building namespace, global namespace, and local namespace. You can only focus on those two, global and local. The building namespace is out of our control. So this is what I wanted to mention about those notions. They are very important. So the global library, I mean, if you want access to the global space resources, that means from all the objects that have been created in the current execution of the Python environment, you can access them using a building function which is called globals. Okay, when you call these globals, you can access to all the objects that have been created during the this currently log of the Python interpreter. That means within this session, I've loaded the kernel of my Python interpreter. When I run this global, you will see this will give me all the objects that have been created so far, representing all the execution I've made. So everything is loaded in memory. As we mentioned for built-in function, they are loaded at the moment you just start your Python interpreter. So they give you access to the global space. You can access to everything. You can see here everything is loaded in memory. And then for everything you want to use, when you use print, it's fine. Those objects in memory and provide that in your working space. You can also use prints inside. You can use globals functions inside prints that will give you the same results. Then if you want to access to a particular topic inside that, you can use key, okay, as methods or a function from the global's function, but you have to provide a key value for you to filter from this data, which is memory, what you are looking for. For example, like this, okay, you have many keys which are already loaded. If you want access to a particular key, for example, when I do this, I can just maybe take this, and then I can provide, for example, here in parameter, like I can filter an object from this dictionary. Let's say name. This is, it doesn't work. What does it say? If you don't remember the syntax, you can use the help. You remember I mentioned how to use that the syntax. Most of the time, for you to figure out about the error, just read what the interpreter show you. You say that there is no argument that has need to be sent to this. Okay, just call it. But for you to access to this, you can take this output, save it in a variable, and then you can filter the object from the variable. Let's say, for example, someone who do this. It can also be possible, especially when you do data analytics inside. I wanted just to show you how you can collect the object from the global namespace. Then I go to the next object, which is return for all the object content in the local space. Since they are loaded in memory, local space, you will get all the resources which are in global space. I will then elaborate on how you can filter that, because I've mentioned that the outputs of globals and locals is a dictionary. For you to access to a dictionary, you have to know the key of every object which is in the global or local space. So you can filter, because this one is an object that can be stored in a variable. You have seen how I've stored that in the GL variable. So now I will show you how you can access, okay, to the contents of whether the global or local variable. You see here, this one will provide a dictionary. From the dictionary, you have to filter based on the key, okay, key of any content inside this object, like cost, okay. If there is any variable which has been named as cost, it will filter and show you. You see, we have used variables like A, it will filter that. If I run this one, you will see it will check if in my memory I've used such kind of variables. So it's found. So this is a dictionary. I've shown how you can get the contents inside the locals, which return a dictionary of symbols. All the objects that are stored in memory. You can see here, for example, my function has been loaded. We have cost, we have score. Everything I've executed so far in my memory, I can find them using local for local variable and global for global variable. I have shown how you can filter. So far, in order to filter, just use the function, and then inside the function, you can filter based on the key of the object you would like to display. Or if you use the function, you can also use a sub function like get to collect that. So this is the only way you can get the objects in the global or local memory. So with that said, I wanted to elaborate on the namespace conflicts, because we say that namespace are defined in order to avoid conflicts with the identifiers. So the Python interpreter give priority to local space first. Like here, you have scope here is defined in the local space, but since it has been defined in the global space, it will automatically be reusable in the local space. Like here, 90, when you call function, at this time, it will just use the local value from inside the function that will be used for the operation. But when you call print score, it will just use this global variable. This is the illustration of the scope of global and local variable. Let's assume like if in your program you have built your logic that depends on this score, but in case the function is called, you may get any result from what you're expecting to get. So it will be a biased solution. So make sure you manage well the naming of any objects you use in your program, depending on the accessibility. That's very important. So if you try to manipulate global variable inside local variable like this, it will raise error. So this example, you can see it's take priority first for the local variable when it's executed, and then the global variable will be also give less priority depending on the place where we call the function. With a local within the local scope, you cannot modify a global variable. Like scope, it has been defined as a global variable. So when you run this code, it will raise an error message saying that the function can only access to the local variable of scope. Okay, that's very important to keep in your mind. And then another example in the way you can modify a global variable, you can either update it with a dictionary syntax or a global keyword inside the 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 function. Here you have var1, var2, they are global variables which are initialized in the global space. You have the function with the string doc that explain the function specification. And then globals, okay, you remember this globals function help us to access the global memory. So from that, you can filter, okay, the objects var1, and then you can now perform operations. This is the data manipulation, data structure, especially for the data structure, you have to know how to manipulate collection of data, because in the globals, you get a collection of data which are represented as a dictionary. You filter them based on the key, which is used to identify the values, which are in memories, and then you can perform operations. So this global also will be used to updates the value inside var2 in the local space. So var2 can take the previous value, which was 30, and then it will ask 20. So when you call the function, although you don't provide any arguments, it will just fetch the values of those global variables in the global space. Here is the example. You will see it will work properly by performing the intended task. So this is very important. And in summary, I can say that functions are very useful, especially for reusing block of codes. It's help organize, simplify the code of our program. And the most important, it's help us to modularize the program in terms of blocks that can be easy to maintain and test. So it provides both built-in and user-defined functions. In terms of building function, we have building normal function, which are available in the standard library of Python. We have also module defined building function, where we have a group of building function which are accessible through the module. The difference from normal building function is that when you just load the interpreter, you have access to the function in memory. But for module building defined function, you have to import the module for you to use that. And then function can take formally defined parameters, which are sent as value called arguments. And then a function can return results, which can be from a result from an expression or a value from a variable. And Python accepts several types of arguments, like positional arguments, key defaults arguments, and then key W arguments, which is used for versatile or and let's say a wide range of argument that can be sent as a collection of values. This is what I can say for the notion of function in Python.